Okay. Marginal and absorption costing. Marginal and absorption costing. Then apart from that, then after marginal and absorption costing, number nine, after marginal and absorption costing, we will have costing methods. Costing methods. The costing methods here are service costing, batch costing, job costing, and process costing. Remember, we're first highlighting the various topics that we expect to cover at the end of the 3 months. Okay? Then number 10, or the 10th topic, is what we refer to as budgets and budgetary controls. And budgetary controls. And 11, we will cover a topic known as standard costing. Standard costing, and the standard costing there, we will mostly deal with variance analysis. Variance analysis. So those, and number 12 is emerging issues. Emerging issues. So those are the various topics that we expect to cover at the end of the 3 months. Now, the first 2 topics here, that is introduction to management accounting here, and cost classification here are theories, and those individual theories, we gave them, or I sent them over to Dennis, or to our cost facilitator, and I want to believe he sent them over to you. So without much talking about that, let's go and talk about cost estimation and forecasting. So I want us to talk about cost estimation and forecasting. So you can write their topic, cost estimation and forecasting. Cost estimation and forecasting is a topic I want us to talk about. Cost estimation and forecasting. Cost estimation and forecasting is a topic I want us to talk about. Cost estimation and forecasting. Now, cost estimation is simply of predicting future cost or is a process. This is simply the study of the relationship between cost. So this is a study of the relationship between costs. Between costs. Now, our costs under normal circumstances, or mostly our costs, we classify them into two. Our costs are either variable costs. If they are not variable costs, they are fixed costs. I'll explain that in a few. Now, the study of the relationship between costs is what we refer to as cost estimation, with an aim of forming predictor equations. Of forming predictor equations. Predictor equations. And now costs are assumed to be linear. So cost relationship is linear in nature. The cost relationship is linear. And it takes the following general form. The following general form. And takes the following what? Takes the following form. Y is equals to A plus Bx. Remember, a linear equation takes the form Y is equals A plus Bx. So we're saying this is a form that a linear equation will normally do what? Will normally take. Such that this y or this y rather, y there, or when we say y, simply means it is the dependent, or the not the dependent, but the independent variable. The independent variable there, which is simply your total cost. Which is simply your total cost. So your independent variable simply means it is your total cost. A there is your y-intercept. The y-intercept, that basically means y-intercept there means it is the value of y when x is 0, therefore it is your fixed cost. It is your fixed cost. It is your fixed cost. That is your fixed cost. Then B is your slope or your gradient. Which is simply the change in y over change in x. Change in y over change in x. Which this means this is your variable cost per unit. Variable cost per unit. Variable cost per unit. Variable cost per unit. Then x here X there is your dependent variable. Or this was the dependent, this should be your independent variable. Independent variable. Which is your output or your activity level or your production. Your activity level or your production. So let me explain this equation here so that you're able to understand, because this is what, or this is the general form of the equations we'll be forming under this method known as cost estimation and forecasting. We must form those equations. Y here means it is the dependent variable, which is basically means the total cost or the cost incurred because you have done what? Produce. Therefore, X here is the independent. Remember, guys, for you to incur cost being a manufacturing entity, you must do what? You must produce. You must produce, and we're saying without producing or without output, we cannot incur what? A total cost, or we cannot incur cost. Therefore, the output or the activity or the production is what we refer to as the independent variable X. And because the cost here is dependent on the output or production or activity level, we refer to it as the dependent variable Y. The Y-intercept is the point, or normally is the value of Y when X is 0. Therefore, that is a fixed cost. And the fixed cost, guys, is a cost that never changes regardless of the number of units done or what? Produced. Regardless of the number of units produced. The B here is the slope or the gradient, which is simply the change in Y over change in X. So it is a variable cost per unit. And a variable cost here simply means it is the cost that changes, or that changes proportionately to the change in what? In output. That basically means it increases as output increases, it decreases as output decreases. So we are saying the difference between variable cost and fixed cost here is that the fixed cost never changes with output. The variable cost changes with what? Output. Variable cost changes with output. So let me develop this further. By giving you the methods of cost estimation and forecasting. And forecasting. Methods of cost estimation and forecasting. Methods of cost estimation and forecasting. Methods of cost estimation and forecasting. So let me give you the methods of cost estimation and forecasting. Now we have two broad methods of cost estimation and forecasting. Number one is what we refer to mathematical methods. Mathematical methods. And mathematical methods here, under mathematical methods, guys, under mathematical methods, you have two broad methods, Number one is ordinary least squares method. Ordinary least squares method. or what sometimes we refer to as simple linear regression method. Simple linear regression method, or just linear regression method. Simple linear regression method. We also have multiple linear regression method, but your syllabus only requires us to cover simple linear regression method. Number 2, or the second method of cost estimation, that is mathematical in nature. That is mathematical in nature, ladies and gentlemen, is what we refer to as scatter diagram or graph method. Scatter diagram, or visual fit method. Or visual fit method. Scatter diagram or visual fit method. Number two is non-mathematical methods. Non-mathematical methods. You have mathematical non-mathematical methods. You have the high-low method. The high-low method. Then number two, you have that other method known as accounts analysis method. Accounts analysis method. Then C, accounts analysis method is the second method under non-mathematical methods. Then that method after accounts analysis and high-low is industrial engineering method. Or measure of work done method. Sometimes also known as measure of work done method. So those are the two main methods that are used for estimation and forecasting. That are used for estimation and forecasting. All right, so you can have that information in your books in the next 2 minutes. So have that information in your books in the next 2 minutes. And we start with method number 1, mathematical methods. So that we start with methods number 1, mathematical methods. So you're writing what is in the board in the next 2 minutes. Right. Now that you've heard from CPA Dennis, let's continue. I want us to start with the first method, known as mathematical methods. So let's start with the first method. Remember, at the end of the day, guys, you see, you must form an equation of the form y is equals a plus b plus bx. So I want to start with mathematical methods. Number one, mathematical methods. Mathematical methods, you have number A, simple linear regression method, simple linear regression method. Simple linear regression method. Now, simply, this is a cost equation method, or is a cost estimation method. That forms equations of the form y is equals a plus bx. Remember, we said that never changes. A plus bx is the equation that is formed such that, ladies and gentlemen, to determine a here, we normally use the following formula. We say a is equals to the summation of y minus b summation of x, all that you divide by n, which is simply can also be the mean of y minus b mean of who? Of x. Then b, say is m summation x, y minus summation of x, summation of y, divide by n summation of x squared minus the summation of x you do what? Square. The summation of x u square. The summation of x u square. So those are the two formulas that we normally use to get the unknowns A, the fixed cost, and the variable cost per unit B, and the variable cost per unit of who? Of B, and the variable cost per unit B. Now let's have an illustration. Let's have an illustration. It is my hope that you have cast the past papers, but in case you don't, let me just give you a question. Let me give you a question. To access the custom past papers via their official page or their official site. So I want us to tackle a question on September 2021, or rather December 2021. This is a pilot paper. This is a pilot paper. Question who? Question 4B. So 4B, and you can take it down. So let me dictate it very briefly. Let me dictate this question very briefly, because I want to believe there may be some of you who don't have that past paper. So they're saying, Kalu Limited produces masks for sale. Kalu Limited produces masks for sale. Masks for sale. Okay. And the following information was provided. Following information was provided for the last 8 months. The last 8 months in mask production. The following information was provided for the last 8 months in production. So I'll be following down. Now the sheets. Okay. So now the past. In the 8th month, that is 5, 6, 6.5, 6.7, 7.5, 8, 9, 9. Then total cost, you have 50, 53, 55, 59, 62, 64, 66, 70, 72. Required. Required there is saying, formulate the cost equation. Formulate the cost equation formulate the cost equation. And show the cost of producing 10,000 producing 10,000 who? Right. So if you see such a question, ladies and gentlemen, the first thing you must realize is that they're telling you to use simple or linear regression method, a simple linear regression method. Let's say using simple linear regression method. One. Simple linear using simple linear regression method. All right. Now, after you have recognized the method that is being used to form equations here, the method that is being used to form equations here, it being simple linear regression method, the next thing you do, guys, is you write those two formulas. You write those two formulas. You write the formula of A, which is there, and the formula of who? B, which is there. Then after that, using the information you've been given, you decide or you select what X is and what Y is. X, we said, is your production, and in this case, they're producing masks. So X here is your number of masks. So X here is the number of masks. Number of masks. Therefore, Y is your total cost. Total cost. The independent and the dependent variables. So that Y is your total who? Total cost. So Y is your total cost. If I can, it's not really clear. Right here, let's see. Total cost. Y is the total cost. All right. Then I want to show you how you deal with this particular question using what? Using your calculator. So I want us to have their shortcut using calculator. Steps using calculator. So I want to give you the steps using calculator. FX82 calculator. I want to give the steps using FX82 calculator, which is allowable in the exam for you to use this calculator. So I want you to go fast. Make sure you have a calculator next to you, preferably an FX82 calculator, and it is what I want to start with. The first step in this case is always to switch on your calculator. So I hope and pray that you have a calculator, and apart from having it, you've switched it on. Then step number 2, or the next step, after switching on, is to press Shift. I want you to press Shift. Then Mode. Shift, Mode, Shift, Mode, then All, which is denoted by number 3 in your calculator. So you're pressing number 3 in your calculator, then equals twice, then equals twice, then equals twice. Shift, Mode, All, equals, so that you reset your calculator. So you are resetting your calculator. Number 2, second step, press Mode. Then Regression, which is denoted by 3. So you're pressing 3, Regression, 3. Then Lean, which is 1. Lean, 1. Such that your calculator will have been set in linear regression mode. Step 3, I hope I'm not too fast. So you say you press Shift, Mode, then All, which is denoted by number 3 in your calculator, then equals twice. Step number 2 is you press Mode, then Rig, which is denoted by number 3 in your calculator, then Lean, which is denoted by number 1 in your calculator. So you press 3 and 1 so that you set your calculator in linear regression mode. Then step number 3 is you input your data variables. You input your data values, and when you're inputting these data values, you input them in the form x, comma, y, m plus. X, comma, y, m plus. You input them in the form x, comma, y, m plus. X, comma, y, m plus. And let me show you how. So we agreed and we decided that x is the number of masks here, y is your total cost. So you're going to input them in this form. You're going to start by imputing 5. So you press 5 in your calculator. You press 5 in your calc. It is my hope that you've done that. Then comma sign is just above the D, L, and AC buttons in your calculator. DEL is just above the L and AC buttons in your calculator. Then the cost of producing these 5 masks, which is 50. Then M plus, just like comma, is above the D, L, and AC buttons. Specifically, it is above the AC buttons. So you press 50, then M plus. So that N is equal to who? 1. The N is equal to who? To 1. N is equal to 1. The next one is you press the next observation, 6, comma, 53. This should be M plus. That N is equals to 1. M plus, if N is equals to 2. So you press 6, comma, 53. M plus, so that N is equal to who? To 2. You go to the next observation, 6.5, comma, 55, M plus. So 6.5, comma, 55, M plus. So that N is equals to who? To 3. N is equals to 3. I want you to continue until you have the 8th observation. I want you to continue until you have the 8th observation. try as much as possible not to make a mistake. But in case you do make a mistake, remember you start with this step. You start with step number. So we are proceeding. We have already recorded the first 3 observations. So we go to the 4th observation. So the 4th observation is 6.7, comma, 59 m plus. That is the 4th observation. 57, 62 m plus. And the 6th is 7.5, comma, 64 m plus. 8, comma, 66 m plus. And 9, comma, 72 m plus. So I want to believe you have n is equal to 8. Let me believe that you have n is equal to 8. N is equal to 8, guys. Is n equal to 8? So now, is n equal to 8, guys? Confirm. So waiting to confirm from your end that it is indeed n is equals to what? To 8. That is indeed you have n is equals to 8. All right, now that you've imputed that, so the next thing you do is you obtain your data values. Obtain data values. Obtain data values. The data values here is the next step, step number 4. And this is how you obtain your data values. I want you to press Shift in your calculator press shift. Shift 1. In your calculator, press shift 1. You're pressing shift, then 1. You're pressing shift, then 1. Now, your calculator will have 3 items. You have the summation of x squared, the summation of x, and n. The summation of x squared is denoted by number 1. So you press number 1, then equals. Number 1, then equals. So that this is 398.39. $398.39. So remember, you're pressing the number shift 1. Then if you want the summation of x squared, you press the number below that. You press the number below that. After pressing the number below that, then you press what? Equals. You press equals. Again, let's go back by pressing shift 1. Let's go back by pressing shift 1. To get the summation of x, we press 2, which is the number below the summation of x, then equals, which is 55.7. 55.7. To get n, you again press shift 1. Shift 1. The number below that is 3. So equals, that is 8. That is 8. That is 8. Then you also press shift 1. Once you press shift 1 in your calculator, they're telling you can move to the right. They're telling you you can move to the right. You can move to the right. Okay. So move to the right with your direction key. The direction key is your replay button in your calculator. It is the biggest button in your calculator. So press it once and press the right side once. Okay. So that you have the summation of y, the summation of xy. The summation of y, the summation of xy. The summation of y, you press 2, that is 481. The summation of xy, after moving with your arrow key, press 3, then equals 34. 10.8. 10.8. Now, once you've done that, you now see what items you don't have. The summation of x squared is right here. With the summation of x is here. The summation n is here. The summation of y is right there, so we don't have that. So the summation of x then you square simply means it is 55.7. It is 55. Then you can substitute it in your formula. You can substitute so that you get the value of b and c. The value of b, for you to get the value of a, you must get the value of b. N is 8. Summation of xy is 3410.8 minus the summation of x, which is 55.7. You multiply summation of y, which is 481. Summation of y is 481. Remember, you're just substituting what we're doing. You divide by n, which is 8. Multiply summation of x squared, 398.39, or x squared, minus the summation of x is squared, which is 55. Which is 55.7 squared. Now, to get these specific individual values, kindly press shift 1. No, rather press shift 2. So you can press shift 2 To get B, press Shift 2. Press Shift 2. Then you move with your arrow key to the right. Move with your arrow key to the right until a place where you're going to meet A, B, and R. And see where you have A, B, and R. So if you want B, you select 2, then equals, so that B will be equal to who? 5.845. 5.845. 5.845. 5.845. Again, press Shift 2. Now, once you've gotten the value of B, you can now substitute the value of B to get the formula of A, so that you get A, So let me show you how. I want to substitute the value of B to get A. Now, already B, A, that's A. We'll say the summation of Y for 81, and there's B 5.845 multiplied by the summation of X 55.7 divided by 8. So again, press Shift 2, move to the right. So press Shift 2, move to the right. You're pressing Shift 2 and moving to the right until where you get A, B, and R. So A is denoted by 1, then equals 19.426. 18.426. Y will be equal to 19.426 plus 5.845. That is the cost estimator equation. Using the method known as simple linear regression method, But they were telling you to also estimate the cost of 10,000 units. So they're telling you to get Y when X is 10,000. X is 10,000 units. So they're telling you to get Y when X is 10,000 units. So simply what you do, you substitute. In the equation, you say Y will be 19 plus 5.845 multiplied by 10. Remember, our values were in thousands of shillings. So this should be 10. That should be 10. That should be 10. That should be 10. That should be 10. We're saying the values there in thousands of shillings. So 27.88. So effectively what that means, that when you produce 10,000 units, you expect to incur 77.88 thousand shillings. You incur to incur 77.88 thousand shillings. 0.88 thousand shillings. 0.88 thousand shillings. So let me ask up to that point. So up to that point, any question, guys? Up to that point, any question? Any question, guys? All right. So that is what we refer to as simple linear regression method, a simple linear regression method. So there being no question, let me give you the advantages. Advantages. So you're writing there advantages of simple linear regression method. Advantages of linear regression method. Advantages of linear regression method. Number one. It considers all observations. Number one, it considers all observations. It considers all observations. Number two, it can be used to where there is more than one independent variable. Or there is more than one independent variable x. And there is more than one, or it can be used where there is more than one independent variable x. Next, validity and reliability of results. Validity and reliability of results can be determined. Validity and reliability of results can be determined. Validity and reliability of results can be determined using coefficient of determination. Using coefficient of determination R squared. Using coefficient of determination R squared and coefficient of correlation R. 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 It is a cheaper method compared to industrial engineering method. It is a cheaper method compared to industrial engineering method. Disadvantages. Disadvantages. Number one. Disadvantages. It is tiresome and time consuming. It is tiresome and time consuming. It is tiresome and time consuming. Number two. It is used by people or by a person. A is used by a person with the required skills. Now next, the assumption that historical cost will repeat itself. Historical costs will repeat themselves is wrong. Is wrong. As costs tend to differ. As costs tend to differ. As costs tend to differ. So let's call it a day. Then as far as industrial, or we can write here the second method, visual fit method, before we call it a day. Let me give you the other method of mathematical. Number two, visual fit method. B, the first one was simple linear regression method. Number two, visual fit method. Visual fit method. Visual fit method. Visual fit method. Say, this is a mathematical technique. This is a mathematical technique. A mathematical technique where costs are plotted. Where costs and outputs are plotted. Where costs and output are plotted in a graph. Are plotted in a graph. And most points that can form a straight line, that can form a straight line, are joined to form a line of best fit. Are joined to form a line of best fit. To form a line of best fit. 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 The line of best fit shows the relationship